Okay, so here's one of the things we're going to learn today, and I'll teach you the long way and the short way. And I probably will never have you do the long way. But, well, you have to do this part. So one way to get the possible rational zeros is you take all of the factors of the last term divided by the factors of the first term. And it's plus or minus. So plus or minus the factors of the last term over the factors of the first term. So these are just possible zeros. So it creates a list, and I'll show you why we used to do this a lot. And they still, like the college professors and these math people, still think it's a great idea, but we aren't going to go through the whole process that they want you to go through for the next steps, because I feel like it's a waste of time with what we have now. So the factors of the last term in this one would be what? What multiplies to be 10? So plus or minus 1, 2, 5, and 10. Factors of the first term. So factors of 2. So now if I were to write down all of my choices, I would take each of these and do plus or minus with them. So like 1 divided by 1 is 1. 2 divided by 1 is 2. 5 divided by 5 divided by 1. And 10 divided by 1. And then I take each of these same top numbers and divide them by 2. So 1/2. 2 divided by 2 is 1, which I already have written. 5 halves. And 10 divided by 2 is 5, which I already have. So plus or minus. So now you have narrowed down your choices of what could be factors to 1, 2, 3, 4, 5, 6 times 2, because plus or minus. So you've narrowed it down to 12. And so then what you would do is you would take each of those and do synthetic division.
Every single one of those.
Every one of those.
No. What?
It is.
That's like 1, 2,
yeah.
5, 6. That's 6 different problems.
It's 12.
12.
Yeah.
Because you have to do the plus and the minus.
So, but you would start and you do like a positive one. So say you did like positive 2. Watch it be the one that works. I'd be kind of frustrated. Not really, but. So you do this. Negative 2 comes down, times that makes negative 4. Negative 4 times 2 is negative 8. Negative 5. Negative 10. Negative 12. Negative 24. So you get a remainder of negative 14. So that would be if it were 2. And so now I'm going to use negative 2. And I hope this works out because I wanted to show you something. But realize you're not going to do all of this, because we're going to use a method that's much better. So negative 2 comes down. Negative 2 times negative 2 is 4. Plus 0 is 4. Times negative 2 is negative 8. Which makes negative 5 is 10. That makes 8 times negative 2. Oh, it didn't work. I was hoping that this would be positive, because if one's negative and one's positive, what does that mean? Like if I have a graph. So negative 2 and negative 14 is down here, right? If I would have done this and the 2 would have been positive value for my remainder, that means that somewhere my line had to have crossed the x-axis, right?
Oh, so it's in between those.
So there'd be something between those. So if you do this and you see that these numbers are opposite signs, you know there has to be a value between those.
So you can cancel off the ones that aren't between.
Yeah. But like I said, that's the long way, and I'm not going to make you do that part of it. So you will have to find possible zeros. Like that's part of your final. They ask you to find list all possible rational zeros. And that's how you would do it. Okay? So here's how we're going to find out where the zeros most likely are. You're going to go to your calculator. And you're going to go to y equals. And you're going to type in what it was, which was negative 2x to the 5th plus 3x squared minus 2x plus 10. And then I hit graph. And I'm zoomed in very closely. And see how that little button by your battery is spinning? As long as that's spinning, it's thinking, and you can't do anything, so you might as well wait for that to finish. But there's one spot where it crosses. But I'm going to zoom out to just a standard. So it crosses just at that point that I can see. So do you guys know how to use your calculator to find a zero? Hit second, trace, and the second one on that says 0, right? So I move it down to 0 and I hit enter, and it says left bound. So where's somewhere on the left side of that point? So that's on the right side of it. I went too far. That's still on the left side. So I hit enter, and now I'm on the right side, and then it says guess. So I'm going to guess like right there. And it says my zero's at 1.465. So that's how we can actually find the zero. Okay? But these are only the real zeros. So far, so good?
So there's 8 more.
Yeah. There's the irrational, well, not the irrational, the complex ones, which are the ones with eyes. So are you ready to find it? Okay. Let's jump into the heart of this today then. I hope this one works. I should try it before you guys try it, but that's okay. You get to see how it all works out together. So there's the problem. What are possible zeros? And even though it says possible, that doesn't mean they're all going to work. These are just some possibilities. Factors of? So 1, 3, because 3/4. 5. 10 doesn't. So 15, 25, and 75. And the factors of the first term are just 1. So those are possibles. Now let's find our actuals. Let's just go to our calculator and graph that. So I go to my y equals x to the 4th minus 6x to the 3rd plus 28. Oh, you guys never do that. Plus 28x squared minus 18x plus 75. Graph. And then we wait patiently for our calculator to do its thing.
Are you gonna have an assignment today?
Very short.
Okay.
Our very short or your very short?
Later and get the assignment.
Yeah. So zoom out. Whoa, stop. I'm going to go zoom fit and see if I can get the screen to show up. So this looks like it never crosses the x-axis, right? So there's no real zeros. So they would all be complex. And without more information, that's all that you could do. But they give you more information. They tell you that x equals 3 minus 4i is a 0. So now what do you do? The book tells you this in the problem. So what do you do now with that information? Any ideas?
You put it into the synthetic.
Yes. So I know that 3 minus 4i is its solution, right?
How did we get 3 minus 4i?
The book tells us.
Oh.
So if x equals 3 minus 4i is one solution, what do you automatically know is another one? Yeah, it's conjugate pair. So we're going to do synthetic division with the green one and then with the blue one. Because we've got to get how many answers? 4. So the 1 comes down. Are you excited about this assignment?
We should spin in more
It's definitely going to be your short, not our short.
Right over my head.
Yeah. So negative 6 plus 3 is negative 3. So 3 minus 4i times negative 3 minus 4i. See, it's a lot of work because you have to do all of this.
It's just not worth it.
And since they're opposites, you know what's going to happen, right? With the middle terms. Negative 12i plus 12i, they're going to go away. And I'm going to have plus 16i squared, which makes a... So negative 9 and negative 16 make negative 25, which just leaves us with 3. And because they told us it's a 0, we know that we better get a 0 at the end or else our math in between was wrong. So that's 9 minus 12i. So negative 18 and 9 make negative 9 minus 12i. So now we've got to take that and we've got to multiply it by 3 minus 4i. So 3 times negative 9 is negative 3 times negative 12i. Negative 4 times negative 9. And negative 4 times negative 12. 48i squared. And the 48 makes, the I squared makes that. So the middle ones go away. Negative 27 and negative 48 make a negative 75, and we get 0. Step 1 done.
Oh.
Wait, wasn't it you have to do that, right?
Yep.
You know, they plug in 0.
Yeah, because you want to get this power from down, you want to get it from a fourth down to a squared. Because once you get it to a squared, then you can use the quadratic formula.
Wait, so we can use all these bottom numbers in our next equation?
Uh-huh. So we're going to go straight from there.
Oh, man.
Sucks.
But if you had to, could you just use the original numbers too?
You could, but you don't want to because you're trying to get this to go down to an x squared.
If the thing equals 0.
Yeah.
So you want to get it to an x squared so you can factor it into
Yeah.
zeros.
But you can only do this if this is a 0 right here. If that's not a 0, you can't do this.
Or could you do it, but it would just be like crazy, or you just couldn't?
There's no point in doing it.
Oh,
Unless you're trying to find if the signs change so that you can see if there's a 0 in between those.
okay.
So the 1 goes down. 1 times 3 plus 4i makes 3 plus 4i, so those go away.
I feel like this is just
Yeah, it's kind of like long division, synthetic division had a child, and this is its offspring. Yeah. And then 3 plus 4i times 3 is 9 plus 12i, and those go away and give us another 0. So that one was much better than the first one.
Oh, wow.
So we started with x to the 4th, correct? This was an x to the 4th. That's an x cubed. This is an...
X squared.
So we now have x squared plus 3 equals 0. So we don't even have to use the quadratic formula. Minus the 3. X squared equals negative 3. Take the square root.
So plus or minus square root of 3.
Plus or minus I square roots of.
Oh, yeah.
3. So there are my 4 answers. There's 2. And 3 plus or minus 4i is 2 more of them. So there's my 4 answers.
Holy crap. That was one problem.
Yeah, it's pretty awesome, wasn't it?
We should do like 5.
Maybe less than that.
Because I didn't even get 5 done in class.
Because I'm probably going to do it like the day before we come back, and I'll forget everything.
So how are you going to find the zeros? Because this first one, you have to find... Oh, I need a page number. So the first one just says find all the zeros. And then it starts off with 2x to the 4th. So you can write down the possible zeros, but how are you going to find out where they actually are?
You have to be like Desmos.
Yeah, use Desmos or your calculator, whatever. And that's going to probably show up if it shows all 4 of them, you're done.
How would it show 4 zeros? Oh, dang. Oh, man.
So there's 1, 2, 3, 4.
Okay.
I put one of those on your test, but I also put one of the others too.
This test won't be like the last one, right?
No.
It'll just be like one of every problem.
Yeah.
That's good.
So these are 3 of the shorter ones. Kind of.
Yeah.
I don't even want to look at them.
You don't want to do that one. You don't want to do any of them. You want to do that one. You really don't want to, but you do. Five problems.
That's pretty enough, right?
No more. Close the book, Hanson.
Don't see any more of the dentist already.
And if you do, we'll do it when we come back. 'Cause none of us are going to remember this anyway.
And one to grow on.
I'm not writing it down. Yeah. We'll just figure out that one.
We'll do these 2 when you get back,
Oh.
because those 2 are fun problems.
Do them what?
Sandra, what is the definition of fun in math?
Hard.
They make you think.
They're awesome.